Good morning, good afternoon, good evening, wherever you may be. Welcome to Good Measure. My name is David and I'll be your host today. Today we have Alex Tui, machine learning research scientist at Wabi and creator of OpenMind. He's here today to talk with us about AI and Wabi. Alex, thank you for being here with us today. Do you mind quickly introducing yourself to those in the audience who may not be familiar with you or your work?
Yeah, sure. So I'm a machine learning researcher and engineer at Wabi. I recently graduated from Caltech and now continuing to do a master's in CS at the University of Toronto with the Wabi CEO, Raquel Erdison, who's also a professor at U of T. So I think in brief, at Wabi, we're building what we think is the next generation of self-driving trucks and high fidelity simulation using an AI first approach. In the past, in addition to what we're working on at Wabi, Raquel's lab at U of T have worked on all parts of self-driving, from mapping, localization, perception, prediction, and planning.
Mm-hmm. So nowadays it seems like AI and machine learning is a term that's being used a lot more in mainstream media. And could you explain quickly what's the importance of AI and machine learning these days in technology and how it's becoming a lot more relevant in our lives?
Yeah, for sure. I think with the rise of the internet, we now have much more information than we could possibly process with our time.
Mm-hmm.
And I think that's one of the biggest areas where AI has taken a hold in our lives. So the ability to recommend and rank results, whether it's from e-commerce or just search, is really important. And that's enabled by AI. But in addition, I think there's two other facets. One is, now we can automate really old labor-intensive processes. One of these obviously is driving, where there is a huge demand because there's a big driver shortage. But in addition, we can also enable a lot of new experiences, especially with the generative models these days, including generating art, generating candidates for drug discovery, among other things. So there's a lot of use cases that kind of close to our lives, but also more industrial as well.
So speaking about AI and driving machine learning, could you quickly tell the audience a bit about Wabi and the sort of closed loop system that's sort of being pushed to sort of test AI in trucking and what exactly Wabi does?
So yeah, I can answer that with some caveat, right? So I can't really talk about what Wabi does uh, and specifically, but I can talk about why these things are important. Previously I published a paper where we were creating a new autonomy system, so for self-driving for a car. And in that paper, it was very important that we use a closed loop simulator in order to evaluate our model. And this is because otherwise, you don't actually know how your model behaves in the long term. So the main difference between open and closed loop is for open loop, you are given, let's say, here's the situation, here's where your car is. Now try to predict where everyone else is going to go and plan what you're going to do in the next second. And so you do some, and then you make a prediction, you do some driving, and then in open loop, you'll then reset back to the ground truth. So now a second has passed, and instead of continuing to do the prediction based off of where your previous predictions, you do prediction instead from the ground truth for the next second, which basically means that you're only testing how accurate your model is on a second by second basis. Whereas in closed loop simulation, you actually try to you stray away from the historical data. So you set up let's say an experiment. Here's where the car is, here's where everyone else is. Now start driving, and you actually will simulate how other actors respond to your car and its actions. So you have to both model your car and also the actions of others.
Mhm.
And that gives you much more realistic measurement of how well your model does, and also better measurement of like how your model does over long term when it's responsible for like following up on its previous actions.
Mhm. So how can we ensure that a closed loop system will be able to test out most scenarios that might happen on an open road? Sometimes there are drivers on the open road who may be intoxicated or who aren't paying attention. How is there a scenario or is there an approach for testing that out in a closed loop system as well?
Yeah, so I think um, there definitely is, but I think there's two things that you want to do in order to make this better. So I think firstly, um, you want to make sure that you're pretty thorough in like the kind of uh, test that you're running. So like in our previous paper, we generated like some scenarios that we knew were going to test some like pretty um, like mission critical like capabilities,
Mhm.
doing like left turns, right turns, etc., to get a broad sweep of what we think the car could encounter in the real world. But I think you can also, and I saw in Tesla's like AI day, um, they had this kind of feature where you can actually um, find instances in real data, historical data, where the car wasn't doing so well, and generate like find more data, or generate data, whatever, of
Mhm.
similar scenarios. So I thought that was pretty cool. And then I think the last thing is you can there's some pretty cool papers on the adversarial learning side
Mhm.
that were published in Raquel's lab, where you actually create scenarios that specifically are going to be difficult for your model. And you
Mhm.
can do that using like predict which scenarios those are using machine learning. So that's another great approach to make sure your system is safe.
Mhm. So artificial intelligence seems to be a very great tool, and it's enabling a lot more safer driving, and the goal is to also increase efficiency and also make up for those for many jobs that cannot be fulfilled. Well, what is with the future and with there being more tech on the roads, how is it possible, or is there ever has there ever been a scenario where and the intelligence has been sort of compromised, or is there any like, let's say a lag in information in which the computer cannot process fast enough? Are there any risks to bringing out like such early technologies? I think that's the better way to say it.
Yeah, I'd say like just industry general, there's always these risks. And um, uh, so I think there's two sides to this. Like the non-machine learning side is to say, that a lot of these like self-driving systems will have a backup in case you think that like, something is going wrong, or things you're deviating more from where you should be. Um, that's and there's a bunch of other different safeguards that people built in, that kind of go back to like how people verify that airplanes are safe, like in
Mhm.
autopilot. So there is an industry for like validating how safe things are. I
Mhm.
will say there's also kind of a separate and pretty interesting branch of research and um, robust machine learning.
Mhm.
Uh, and so in that field of research, you can kind of actually make theoretical guarantees that prove that your model isn't going like with a very low probability is going to deviate outside some expected set of um, actions that you've previously seen. And
Mhm.
so I think that's also pretty interesting because this is true in a lot of fields like banking, not just self-driving. And so people are developing models that just by training it a bit differently, you can constrain what it's going to output.
Mhm. And so, what are some other uses that you may be using machine learning or AI for? Is AI a good tool for combating misinformation on the internet?
Yeah, totally. So, as you mentioned at the beginning, I'm also a co-founder of Open Minds. And so we are essentially a Chrome extension that helps news consumers improve their media literacy and also like fight misinformation. And so um, the way we use AI is kind of so there's a lot of like other works using AI to identify misinformation and actually, being able to predict what this is based on its content is not very easy
Mhm,
because there's very subtle things you can change um, that can make something turn from true to misinformation. And if you look at these papers analyzing like GPT-3, so these,
mhm,
giant language prediction models, they
mhm,
actually, the more intelligent they get, like the bigger they get, the more easily they memorize misinformation.
mhm,
And so um, I think one promising way to find misinformation is actually looking at the metadata, like seeing, is this a trusted publisher? Are they linked to other like previously identified forms of misinformation? And that's sort of what we do with Open Minds. I think there's, however, like a much more important second piece to this, which is ultimately we need to train people in like identifying misinformation and thinking
mhm,
critically, not about just even like explicit, misinformation, but biases um, and kind of wordplay that can really say something different about uh, some topic in the world without being false. And
mhm,
so at OpenMind, we recommend an anti-news feed. Basically, we analyze what people are reading
mhm,
and actually show them an article that puts a different perspective or disagrees with what they already read.
mhm.
So that way, basically, they have an automated way of seeing both sides, which we think uh, we've seen in studies on users kind of pushes them more towards like a centered or at least more rounded view.
Mhm. And for those in my audience who are sort of relatively new to machine learning and AI, what are some resources that they would should look up or read to learn more about machine learning and AI? And is there anything that you'd like to sort of push to the audience and sort of like say like or recommend them do when it comes to learning this topic?
Um, yeah, so let's see. And so just to clarify, would you say your audience is like high school, above, below?
It's around like high school to college-ish.
Okay, okay, yeah, perfect. Yeah, so I think there's two aspects to like machine learning. One is knowing how it works, like mathematically, and the other one is programming with it. So I don't think you need like anyone can start programming with machine learning because if you go to hackathon, there's all these like APIs that allow you to um, like use machine learning. So like let's say you wanted to like predict the next word in a sentence, or you want to
Mm-hmm,
classify an image, right? Like as long as you can think of the right use case, you can use those tools and like create applications and things people want. I think people wait too long to like try those things.
mm-hmm,
But I think on a mathematical side and doing research or just being able to improve and create new models,
mm-hmm,
I think after having like some like a calculus course, which I think is pretty important, you're basically ready to go and like learn machine learning online. Like before I took my machine learning course at Caltech, I was working on online courses, right? Like
mm-hmm.
there's tons of them from Coursera to Udemy. Like Google has a great machine learning crash course, in my opinion. If you just like search that up. Um, and so I think those are great places to start. That anyone with some calculus background ideally would be able to do.
All right, sweet. Well, that's it for today. Thank you so much for being here.